Hi there, seems like it's been a while since I had a Dell to review. The last one was the Dell PowerEdge R770 rack server, and you can see that one here. Today, and I can say that for as many years as this video will be on YouTube, we have the Dell PowerEdge R670 rack server, also part of the 17th generation line of servers. Coming soon, I'll also be reviewing the Dell PowerEdge R570, but we'll get to that. Focus. Buckle up and let's get to it. The Dell PowerEdge R670 is a 1U dual-socket system hosting Intel Xeon 6 processors, plus some high-density storage with up to 20 EDSFF drive bays in certain configurations, loads of memory, and optional liquid cooling. The tradition of an overwhelming number of options continues with this PowerEdge R670. What's it good for, you may be asking? Pretty much everything. I mean, is it really necessary to make several iterations of servers anymore? While you mull that over, Dell says it's good for hyperscale workloads, scale-out database, virtualization, cloud-native applications, and I'm sure a lot more, which I will sprinkle in as we go along. Let's start with the front of the chassis. There is an option for a security bezel, also the option of a front or rear I/O configuration, but that's just the beginning. There's only one front I/O configuration for storage, and it comes with 8 EDSFF E3.S NVMe drive bays. From there, we return to the rear I/O configuration, and there are several storage configurations using EDSFF E3.S NVMe drives. There's an 8-bay EDSFF, 16-bay EDSFF, 20-bay EDSFF, and option to install 2 more EDSFF in the rear, but we'll get to that. Next, chassis configurations with 2.5-inch drive bays include an 8-bay for SAS, SATA, NVMe drive types, another 8-bay version with a universal backplane where you can load whatever drive type in any of the slots. Lastly, a 10-bay version for SAS and SATA drive bays. Are you interested in the Dell PowerEdge R670 server? We can configure it any number of ways to satisfy your business needs. Even better, you can save up to $500 off the purchase price of a system that's listed or one that you can configure at IT Creations that's valued at $5,000 or more. Just click that link to learn more, and when you're ready to make a purchase, just mention this video. The only real problem will be deciding on the list of options. Good luck with that, but we can help you with that too. itcreations.com. There is a small control panel on the left with USB port and a mini display port. The KVM module is optional, meaning no USB port or mini display port. You also have another option that incorporates Quick Sync 2 for all chassis management of the system using a smartphone or tablet. On the right-hand side, you get a System Health LED, System ID button LED, power button, Type-C USB port, and the host status LED, which is that little wrench icon. That would be consistent with the front I/O configuration as well. Ordinarily, I might move around to the back, but let's check out the front I/O configuration first. You still get the same control panel options I just mentioned, but you also get a dedicated iDRAC Ethernet port and a serial COM port. Adjacent to that, you have the option to install a boot optimized storage device or BOS. Next, a storage cage with 8 EDSFF E3.S drive bays, then the primary OCP NIC with a secondary OCP card slot above. The primary OCP card slot shares a NIC port with iDRAC, but both are OCP 3.0 compatible. The other 8-bay configuration looks quite similar in front, but the PCI slots and OCP card slot have cover panels. The other drive configurations with 16 and 20 bays have a 5-drive cage layout with 4 cages occupied on the 16-bay and all 5 drive cages used for the 20 drive bay setup. Lastly, the no backplane setup with no drives in the front drive bays and all 5 drive cage locations outfitted with a perforated cover panel for airflow. Still got to keep it cool. The back of the front I/O configuration still houses dual power supply units and a few PCI slots at the back of the chassis. There are several options for the PSUs depending on the configuration. Still looking at the front I/O version, it has a small I/O panel with VGA port, dual USB 3.0 ports, and a dedicated iDRAC port. Then the system identification LED. In this case, the OCP card slots are covered as the OCP connections have been moved to the front of the chassis. That dedicated iDRAC port on the back of the chassis enables remote management of the system. With this server line, Dell has introduced iDRAC 10. Additional management utilities supported on this platform include some new applications, including Native Edge Endpoint and Native Edge Orchestrator, which run in a special secure operating system. Those last two are for edge applications, but also provide a compute foundation for distributed data centers. Dell OpenManage is also supported, plus a command line interface. OpenManage also provides integration with Microsoft Windows Admin Center, VMware vCenter Plus, connections with third-party management utilities. The back of the other configurations that do not have front I/O include that same I/O panel on the back I just mentioned, but those OCP 3.0 mezzanine card slots are now active. One of them is specifically for Dell's Boot Optimized Storage System, aka a BOS, or an internal M.2 interposer board for internal system boot. Is the interposer board the same as the Dell BOS? No. It does not have access from the rear of the system to swap drives easily, but does still have two M.2 drives. Also, there's no RAID supported like that on the BOS, which is a small controller that offers RAID 0 or RAID 1. There is a small cover panel next to the right-hand side PSU, where optional liquid cooling tubes would be located, providing for both an input tube and output tube. Once you remove the cover, you can see two risers supporting expansion devices, standard PCI, and CXL 2.0. Again, a bunch of riser options with either 3x16 or 2x8 Gen 5 slots and other combinations between. Beneath those two risers are the BOS module slot, the OCP NIC card slot, then the motherboard with associated DIMM slots, a row of fans, and then the backplane for the upfront storage devices. If this was the front I/O model, you would see a front riser on the front left and BOS module slot in front on the right, separated by the storage backplane in the middle. With the non-front I/O version, there is the option to install a front PERC storage controller. As I said earlier, the PCIe 5.0 slots also support CXL 2.0 devices. The CXL protocol runs across the standard PCI physical layer. There are many different forms of CXL devices, including the more recognizable options like NICs, storage controllers, and GPUs. But one of the unique things you can do with CXL 2.0 is install additional memory through a CXL memory expansion add-in card. It fits into one of the PCI 5.0 expansion slots, which is also CXL 2.0 compatible and uses the PCI 5.0 interface. This additional memory provides advantages for memory pooling and resource sharing, plus improved ROI for data center and high-performance computing environments. The memory pools can be accessed by multiple hosts, significantly increasing overall memory utilization. Form factors for these memory expansion devices include a PCIe form factor as well as EDSFF form factors. With that last, you can scale memory on the fly without powering down. The module is installed in a CEM slot with a x16 link width outfitted with 4 DIMM modules for an additional 384 gigabytes of memory. By the way, in this respect, CEM is referring to a card electromechanical specification, the PCI slot and card interface. This memory can be allocated a number of ways, but in a more basic context, either conventional memory mode, aka general purpose memory mode, or special purpose memory mode. With conventional memory mode, the CXL memory is directly mapped and added to the system's physical memory and is visible in UEFI. The CXL memory appears with the standard DDR5 memory as a unified resource. With special purpose memory, the CXL memory can be allocated separately from physical memory to support specific applications. Per CPU, you can install up to 4 of these CXL add-in cards, but with the R670, we only have a maximum of 3x16 slots. Therefore, at maximum, only 3 of those cards can be installed, and then you would be depending on that lone OCP 3.0 mezzanine card slot for additional network communications. GPUs would also be considered a CXL device. This system can be outfitted with up to 3 75-watt GPUs. That power limit would include the NVIDIA L4 24GB, but also the NVIDIA Tesla T4 and the NVIDIA A2. No auxiliary power is required for those cards, as the PCI slot provides up to 75 watts of power. The system is powered by dual Intel Xeon scalable processors from the 6500 or 6700 series with either P cores or E cores, at least at this point in January of 2025, or thereabouts. P core and E cores do not mix, so you have to choose one or the other. I will mention the following comparisons are with top-of-the-line CPUs in each category. With E cores, you do get more of them with up to 144 cores compared to CPUs with P cores that can provide up to 86 cores. However, CPUs with P cores have Intel hyper-threading technology for up to 172 virtual threads. E cores, on the other hand, do not have Intel's hyper-threading technology, but still up to 144 physical cores and 144 virtual threads, plus better energy efficiency. If you want more information on Intel Xeon 6 processors, I did a short video and you can see that up in the upper corner. In total, there are 32 DIMM slots divided between the two processors for 16 DIMM slots per CPU. The processors support an 8-channel memory architecture, so up to 2 DIMMs per channel at capacity. And at full capacity, which usually never happens anyways, the system can be outfitted with up to 8 terabytes of DDR5 registered DIMMs. There are 4 dual fan modules installed in this platform, either high-performance silver or standard hot swappable cooling fans. Those fans suck in air through the front panel and blow over the CPU's memory modules and finally out the back of the chassis. Hardly a full accounting of all the various options on the Dell PowerEdge R670 server, but it will have to suffice. There are a ton of options on the system, and those CXL memory expansion devices bring another layer of possibilities to system performance. If you like this video, give it a thumbs up. If you want to learn more about this system, then I placed a few links down below, or you can use that one right there. There's also a link to the specifications. itcreations.com. Until next time, I'm Doug Stewman with IT Creations, and thanks for watching.